So now moving to the next question of binomial here, bachcho. So that's the question which you would have got today. See, the importance of this question is what I call the Bahubali property. Now that's a very common and a very important property in definite integral. Okay, so when you will be solving the questions of definite integral, there's a property which says that integral of f of x dx, and the students who are in the 11th class, they might not be knowing it, but still I will discuss it with respect to the summation series also. But let's look at it first for definite integration. It is like a to b integral fx dx. Now the property says that it is equal to the integral from a to b itself, but if you replace x by the sum of the limits minus variable. The variable of integral is x, the sum of limits is a plus b. So if you replace x, the variable of integral, within the integral sign, within the function, by sum of limits minus the variable a plus b minus x, the value remains same. Okay, now if we discuss it with respect to this property, it says that summation f of r goes from 0 to n. Okay, so now the property is very simple. It says a plus b, a 0 are the initial value or the starting limit of r is 0 and the last value of r is n. So the upper limit is n, lower limit is 0. So you add them, so 0 plus n is n, and replace r by a plus b minus r. So n minus r. The value remains same. Okay, and see that you can very easily verify or check or prove by expanding both the terms, by assigning values of r here from 0 to n, r here from 0 to n. Okay, it's like writing this one is from 0 to n and this one is from n to 0. So of course that won't make any difference. Okay, now I'll be using this property here where I have to find the value of t, let's say, which is r goes from 0 to n, r upon NCR. So r goes from 0 to n, r over NCR. Okay, so I will say, okay, let's rewrite it by using Bahubali property, which says that we can replace the variable of the summation here, which is r of course, by the sum of the limits of r, 0 and n, so it's n minus r. So replace r by n minus r. Of course, NC, n minus r is same as NCR for us. Okay. Now see, that's what I always suggest for definite integral also, that after using Bahubali property, the normal course of solution is add the given expression and the expression which you obtain after applying the property. The same thing I will suggest here also. So add them, to t plus t is 2t, and here see, when you add them, r goes from 0 to n, denominator is same, numerator add up, and then r gets disappear, and n is a constant with respect to your limit or variable of the summation, which is r. Now this is given to us, bachon. So what is it? So that's s. So therefore t is nothing but n times s by 2. So that should be the answer for this series here. So though that was a question which seemingly, like we have used the property of binomial coefficient, NCR is equal to NCN minus R, but more likely this is more a question of the Bahubali property, the property of summation here, bachon.